Today we're going to cover Riemann sums to find the area underneath of the function. There are many types of Riemann sums out there. Today you're going to be learning the left-hand rectangle method and the right-hand rectangle method. There's also the midpoint rectangle method, but we won't be covering that. So let's get started. When you're doing the left-hand rectangle, that means that you start your rectangles with the left top vertice of your rectangle hitting the function. So my rectangle would start right here, and I would draw it across to the first unit, because the smaller the rectangles, the more accurate your area is going to be, and draw my first rectangle. Then I'd go to where it hits on the next unit, draw another rectangle coming from there. As you can see, my vertices on the left hand side of these rectangles are touching the function. Okay. And you keep doing that until you've gone the whole interval, which on this one is from 0 to 10. Okay. So you just keep going like so. So all of your rectangles are drawn. Okay. Now that you've got your rectangles drawn, the next thing you do is you've got to find the area of each of these rectangles. Well, the base of your rectangle here is from 0 to 1, which is just 1, right? And that's the base of every one of these 10 triangles you have. To find the height, you use the part that's hitting the function, the height that's hitting the function. Now, my x value is 0. Do you see how they gave you the function? So you just plug in 0 times 1/2 plus 4, and I would get 4 here. Then the next one I'd plug in 1. 1 times 1/2 is 1/2 plus 4 is 4.5. And so on until you get all of your areas of your rectangles. And what's cool is once you get the height of this rectangle, you just multiply it by 1 to get the area. So you know all the areas of the rectangles, and then all you do is add them up. So I'd add 4 plus 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7 plus 7.5 plus 8 plus 8.5, and that would give me an approximate area of 62.5. The reason we use the approximate symbol is because this is not the actual area. As you can see, we've left out quite a bit of space here that is not included in this area. So it's not totally accurate, but it's approximately that area. Okay? So now let's do the right-handed method. The right-handed method is the same way, except the right side vertex of the the rectangle is going to hit the function. So as I start, I can't draw one from 0 because it would go to the negative, and we don't want that. So I have to start at 1 and go up where the function hits and draw my rectangle back to 0, because it is from 0 to 10. Okay? Then I go up to over to the next unit and I do the same thing. The right hand vertice of the rectangle, the top right vertice of the rectangle, hits the function, like so. And I keep doing that until I've drawn all my rectangles in. Okay? Now, when calculating the areas, I now cannot start at 0. I have to start where this function first hits one of my first rectangle, which is the rightmost side. So I would start by plugging in 1 into my function, and that would give me 4.5. Then I'd plug in 2, and that'd give me 5. I'd plug in 3, and that'd give me 5.5. 4 would give me 6. 5 would give me 6.5. And again, all you do is you add them up. 4.5 plus 5 plus 5.5 plus 6 plus 6.5 plus 7 plus 7.5 plus 8 plus 8.5 plus 9, and that gives me an approximate area of 67.5 units squared. Now if you notice on this one, the reason it's approximate is we were over this line by quite a bit. So that part of the area of those rectangles is not actually part of the real area. So again, it's just an approximation. Alright, that was with straight lines. Let's look at how to do it when you have curved lines. Again, it's the same principle. We're doing the left-handed right now. This is the left-hand rectangle method. Okay? So if I do the left-hand rectangle method on this function, 1/8 of x minus 6 squared plus 4, then I would still start the left-hand side of my rectangle on the function at 0 and draw it across and come down. And I do that all the way across, and you're going to see as you come down the curve, you're going to be over the rectangle, and then you're going to be under the rectangle. Okay? And it comes out like so. Again, for left-handed, I start at x is 0, and I go all the way to x is 9. I can't use 10 because 10 would start up here and go off into another dimension, and we're only going up to 10. So 0 through 9 is what I would plug in. The easiest way to do this, to get your numbers, is to go into your calculator, into the table, and type in your function, which would be 1/8 times x minus 6 squared plus 4, and then put that into y1, and then hit menu, go down to table, and show table. So the easiest way to do that is I now start from 0, and at 0 at 0, my answer would be 8.5. Then at 1, my answer would be 7.1. Then at 2 would be 6. Then at 3 it would be 5.1. At 7 it would be, at 4 it would be 4.5, then 4.1, then 4, then 4.1, then 4.5, and then 5.1. Now if you look at these areas, what are you noticing? They go down to 4 and then they go back up at the same increment, which tells us this particular function is a parabola, makes the shape of a parabola, which means it's probably a quadratic, which it is because there's the squared. Okay, so I have a quadratic function here. I'm trying to find the area under the curve. So I add all these together. So I add all those together, and I come out that the area is approximately 53.1 units squared. Okay? So that's the left-handed method. Now, I want to do the right-hand rectangles. Again, same thing. I start from the right, so I'm going to start way over here and draw my first rectangle. Okay? Then draw my second, and draw my third. Okay. So now I'm not starting at 0, I'm starting at 1 and going through 10. And at 1, it was at 7.1. Let me draw that a little lower. That way they all look the same. At 1, it was 7.1. At 2, it was 6. At 3, it was 5.1. Okay, and we'll keep going. So 7.1, 6, 5.1, 4.5, 4.1, 4, 4.1, 4.5, 5.1, 6. Again, we add all those together, and our approximate area here is 50.625 units squared. Okay. Alright, now you've seen how to do Riemann sums. If you have any more questions, please feel free to come and ask.